Hello everyone, here we have a SAT math problem. Okay, let's go to the question. F of t equals to 55 times t negative 2t square. The function f is defined by the given equation. The function g is defined by g of t equals to f of t positive 3. Which expression represents the maximum value of g of t? Okay, in the given answer choices, I have to find the one which represents the maximum value of g of t. Okay, now we can use Desmos to solve this problem easily. Okay, let me give the first function f of t as the input in Desmos. That is f of t equals to 55 times t negative 2 times t square. Okay, now let me take the function g of t as input. That is g of t equals to f of t positive 3. Okay, now let me add the graph of f of t because we need the graph of g of t. Here we have the graph of g of t, and it's a parabola. Since it's a parabola and also it opens down, the vertex of the parabola will give the maximum point. This vertex, the y-coordinate 381.125 will give the maximum value of the function g of t. Okay, now let me take the point over here. So this vertex, let me consider only the y-coordinate, I mean the vertical coordinate. So 381.125 is the maximum value of g of t. Now we have to evaluate the value for each expression in the given answer choices, and I have to get the one which gives exactly this value, 381.125. Okay, now let me calculate the value of the expression in answer choice A. That is 3 positive 55 divided by 4, and it has to be squared. Okay, when I evaluate the value of the expression in answer choice A, I am getting 192.0625. I don't get this value, 381.125. Okay, now let's evaluate the value of the expression in answer choice B. For that, we have to multiply 55 or 4 the whole square by 2. When I do so, I am getting 381.125. That exactly we have over here. So the expression in answer choice B gives a maximum value of g of t. The correct answer choice for this question is B. Here we have the next problem. The function g is defined by g of x equals to absolute value of x divided by a negative 14, where a is less than 0. What is the product of g of 15a and g of 7a? Okay, let me take the function g of x as input in Desmos. It is g of x equals to absolute value of x divided by a negative 14. And the question says a is less than 0. That is, we can take some negative value for a. Let's use a slider over here and take some negative value for a. Okay, here I'm taking a equals to negative 1. And our aim is to get the product of g of 15a and g of 7a. Okay, now let me multiply them. That is g of 15a times g of 7a. Okay, when I take a equals to negative 1, the product of g of 15a and g of 7a is 609. What if I take a different negative value for a, like negative 2 or negative 5, something like that? Whatever negative value I take for a, so the product of g of 15a and g of 7a does not change. It remains same. That is 609. So therefore, the product of g of 15a and g of 7a is 609. Here we have the next question. Consider the line Q, which can be written as y equals to mx plus to b. It is given that the points 2a, 4, negative 3a and 4a, 4, negative 6a lie on the line Q. Determine the value of b. Okay, here in this question, we have to find the value of b, which gives the y-coordinate of the y-intercept of the line Q. Okay, let me take the given 2 points as input in Desmos. Let me click on persistent, go to the table, and the first point is 2a, the corresponding y value is 4, negative 3a, and the second point, the x-coordinate is 4a, the corresponding y value is 4, negative 6a. And here a is a constant, and we don't have any restriction for the value of a, because the question does not say whether the a has to be positive or negative. Since there is no restriction for a, we can take some random value for a. Let me take a equals to 1 for my convenience. Okay, let's click on over here, and here I got the equation of the line Q, that is y equals to negative 1.5x positive 4. Okay, when I compare this y equals to mx positive b and y equals to negative 1.5x positive 4, at the place of b, we have 4. And here we got value 4 for b when we take a equals to 1. What if I take some different value for a other than 1? Okay, now let's use a slider to take some different value for a. Okay, even when I take different values for a, the equation value over here does not change. So therefore, the value of b in this equation is 4. Here we have the next problem. One of the factors of 2b cube negative 24b square positive 70b is a b negative c, where c is a constant. What is the largest possible value of c? Now to solve this problem with Desmos, let's replace b by x in both of the given expression. Okay, now let me replace b by x in the first expression. Then we have 2x cube negative 24 x square positive 70x. When I replace b by x in the second one, I'm getting x negative c. The question says this b negative c is one of the factors of this expression. Then this x negative c must be one of the factors of this expression. Now let's equate this factor to 0 and solve for x. Okay, let me do it. Now add c to both sides of this equation. Negative c, positive c will cancel out. We get x equals to c. Since x negative c is one of the factors of this expression, then this c must be the exponent of one of the x-intercepts of the graph of this expression. Okay, now our aim is to get the x-intercepts of the graph of this expression. Once we get the x-intercepts, we can find the largest possible value of c by looking at the x-coordinate, the x-intercepts. Okay, now let me take this expression as input to get graph in Desmos. Okay, let me give this expression, that is 2 times x cube negative 24 times x square positive 70x. Okay, here we got the graph. Let's consider the x-intercepts. We have 3 x-intercepts. Already we know that this c is the x-coordinate, the x-intercept, and we have to get the largest possible value of c. So we have to consider the x-intercept where we have the largest value for the x-coordinate. So that's in the x-intercept 7, 0. So here we have 7 as a x-coordinate. So therefore the largest possible value of c is 7. Here we have the next problem. The functions g and h are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the minimum value of the function it defines where x is greater than or equal to 0? We have 2 functions over here, g of x and h of x, and we have to find the one which displays its minimum value as a constant or coefficient. And for both the functions, we have the domain x is greater than or equal to 0. Now let's get the graphs of both the functions g of x and h of x in Desmos. Let me give the first function g of x as input. That is g of x equals to 18 times 1.16 times 1.14, and it has to be raised to the power of x positive 2. Okay, here. And also we have to give the domain that is x greater than or equal to 0. Here I got the graph of the function g of x. Let's get the minimum value. Okay, here to get the minimum value over here, consider the y coordinate of the point over here. The y coordinate is at 27.13565. Now in the function g of x, we have to check whether this minimum value, that is y coordinate at this point, is displayed as a constant or coefficient. No, this value 27.13565 is not displayed as a constant or coefficient over here. So we can reject the first function g of x. Okay, now to get the graph of the second function h of x, let me give it as input in Desmos. That is h of x equals to 18 times 1.4, and it has to be raised to the power of x positive 4. Okay, let me do it. And also we have to give the domain, that is x is greater than or equal to 0. Here I got the graph of the second function h of x. So its minimum point is 0, 69.1488. So to get the minimum value of the function h of x, we have to consider the y coordinate of this point, that is 69.1488. Now we have to check whether this value is displayed as a constant or coefficient in the function h of x. No, this value 69.1488 is not displayed as a constant or coefficient over here in the function h of x. We can reject the second one as well. So both the given functions do not display their minimum values as constant or coefficient. The correct answer choice for this question is neither one nor two.